Hello dears, welcome to my channel Maths by U By Attaur Rahman. In this lecture, we are taking up grade 12 Mathematics Unit 1st. Here, we will try to prove the theorem. Limit x goes to 0, sin x by x is equal to 1. But before going into the detailed proof of this theorem, let me share something important regarding this theorem. The first one is the area of the triangle. As we know that the area of the triangle is half base into altitude. The second one is the area of the sector. The area of the sector is half square of the radius into the radian measure of the central angle of the sector. Let us prove the theorem. So consider a unit circle having center at the origin O. We know that a unit circle is a circle whose radius is equal to 1 unit. Further, consider x, the radian measure of the central angle of the sector AOB. That is, this angle lies between 0 and pi by 2. Let us draw a tangent to the circle at the point B from the point C. Now draw a perpendicular BD from B on x-axis. That is, measurement of BD is equal to h. Now we finally join B with A. Now we separately consider the area of the figures involved in the diagram. So now we first consider the area of the triangle AOB. That is, let delta 1 is equal to 1 over 2 base multiplied by altitude. Here in the diagram, we see that base is OA and altitude is h. But we have considered that the circle is of a unit radius. That is, the length of OA is equal to 1. So we have half into h. Now in the triangle BOD, if we find sine, it gives h is equal to sine of x. So the area of the triangle AOB is now delta 1 is equal to half into sine of x. Suppose this is our first relation. Now secondly, we want to find the area of the sector AOB. So the area of this sector is delta 2 is equal to half into square of the radius of the circle into the angle formed in the sector. That is 1 over 2 into OA square into x. But OA is equal to 1, so the area of the sector is delta 2 is equal to half into x. Mark this as our second relation. Finally, we want to find the area of the triangle COB. Let us denote this area by delta 3. Thus, delta 3 is equal to half into base, that is OB, and into altitude, that is CB. But OB is equal to 1. And in this triangle, tangent of x is equal to BC divided by 1. Thus, BC is equal to tangent of x. Now replacing BC by tangent of x, delta 3 is equal to half tangent of x. Mark this as our third relation. Now it is quite clear from the figure that delta 1 is smaller than delta 2 and delta 2 is smaller than delta 3. That is, the area of the triangle BOA is smaller than the area of the sector BOA. Also, the area of the sector is smaller than the triangle COB. This implies that half of sin x is smaller than half of x, which is smaller than half of tangent x. Now multiplying throughout this inequality by 2, we get sin x is less than x, x is less than sin divided by cos, because sin divided by cos is equal to tangent of x. Now dividing throughout this inequality by sin x, we have 1 is smaller than x divided by sin x, while this one is less than 1 upon cos x. Or we can write this 1 is greater than sin x by x, which is greater than cos of x. Now applying limit to each side of this inequality, that is, limit x goes to 0. So limit x goes to 0, 1 is greater than limit x goes to 0 sin x by x, which is greater than limit x goes to 0 cos of x. As the left extreme side of this inequality contains a constant function, so limit x goes to 0, 1 is equal to 1, while the right extreme side of this inequality contains a function, that is cosine function. So limit x goes to 0, cosine of x gives 1. Thus by a sandwich theorem, we have, since we see that limit x goes to 0 sin x by x is a sandwich between 1 and 1. Thus, by sandwich theorem, we have limit x goes to 0 sin x by x is equal to 1.